Hello everybody! Today I'd like to introduce you to my pet project. It's a mini framework for automated testing for devices managed by the Blynk platform. But first, let me say a few words about the devices for which the tests were created. The device is based on ESP8266 microcontroller, runs C++ code communicating with Blynk platform. Let's go to the Blynk platform. I will show auto tests written for the device with the nickname BoxerOne. It has sensors for monitoring temperature, humidity, luminosity, and infrared motion sensor. The Activate Detection switcher defines the device mode. Firstly, let's consider Activate Detection is off. In case of motion, the date and time should be updated. In case of luminosity rises above luminosity threshold, the date and time should be updated as well. Now let's consider Activate Detection is on. In this mode, some additional actions should be performed. In case of motion, Alarm Move LED should be yellow. In case of luminosity rises above luminosity threshold, Alarm Light LED should be yellow. To test the features of BoxerOne, we use the Double Switcher 2 device. Let's go to the Double Switcher 2. It has two smart sockets. One turns on the light and the other triggers a motion for BoxerOne. Now let's get back to the tests. All tests can be found in my Git repository via this link. I have also pinned this link to my LinkedIn profile. As you can see, the repository contains two folders. The NodeJS tests folder contains tests created using the NodeJS platform with the Mocha test framework. In the Selenium tests folder, you can find tests created using Selenium IDE. Additional details can be found in the README file. All actual tests are located in the main branch, while tests under development reside in corresponding feature branches. In this video, I'll demonstrate the test structure created using the NodeJS platform with the Mocha test framework. To use this framework, you should install Node.js and Mocha on your computer. For further work, I will open the project in Visual Studio Code and explain the project structure before moving on to the tests. As you can see, the Node.js test folder contains two subfolders, Common and Test. The Common folder includes Action and Config folders. The Action folder contains the following files. Common Actions file contains functions that don't depend on device type, such as login, switch to device, get system time, get data stream value, set data stream value, and others. I'll explain these functions later. Boxer Actions contains functions specific to Boxer devices, such as our BoxerOne. For example, get current activate detection state, switch activate detection state, do move, switch light on, switch light off, and others. I'll explain these functions later as well. The config folder includes the devices file with configurations for devices. The main objects file contains the code that allows us to use the Selenium WebDriver library and create a WebDriver instance and use the Chrome browser. Firstly, we extract the builder class from the Selenium WebDriver package. The builder class is part of the Selenium WebDriver API and is used to configure and create instances of WebDrivers. This code creates a new instance of the builder class and configure it for the Chrome browser. The build method is then called to instantiate a WebDriver based on the provided configuration. The resulting driver object can be used to automate interactions with a Chrome browser session. Also, in this file, we declare global variables that will be available from any part of your Node.js application. Moving on to the test folder. It contains two subfolders, Aquarium and Meteor Boxer. Now we are exploring Meteor Boxer, so let's open the Meteor Boxer folder. Let's open file test Meteor data, and I'll explain in the test structure. First, we define global variables that we will use in the test suite. Next comes the describe block. All browser actions should be performed asynchronously because after each request, the runtime environment should wait for the browser's response. That's why we use asynchronous functions for such cases. The first in the block is the function before. It's used once to perform some actions before running the test suite. For example, open browser and logging into the Blynk account. Next, we have an after function. The code inside the after function runs once after all the test cases have been executed. This allows us to return the device to its original settings and close the browser in which the tests are run. Following are the functions before each and after each. They are used to perform some actions before and after each test case in a test suite. As you can see, we use console log before and after each of the listed functions for ease of reading logs when running a test suite. Next, in the actual test suite, we check the various metadata of the Boolean Boxer 1. The test has a number and the purpose of the test is clear from its name. To run this test suite, we should use the next file, boolean test metadata. Let's consider this file in detail. This line of code imports the Mocha module, which is testing framework for JavaScript. This line of code creates a new instance of the Mocha class. Further, we declare the global variables that store configurations from the devices file for devices which the test suite runs for. This line of code adds the specified test file to the Mocha test suite list. This code initiates the execution of the Mocha test suite, running the test defined in the edit file. To run a suite, switch to console, tap terminal, go to the Blynk project NodeJS tests folder, and then use the command Mocha and indicate the path to the file that runs the suite. Let's run test metadata test suite. I am going to briefly explain the test run. A new browser instance is opened. Logging into the account. Switching to Boolean Boxer 1. Checking the online status. See luminosity is 0. Turning the light on. Returning to Boolean Boxer. You can see the luminosity has been updated. And finally, closing the browser. According to the test logs, all functions before each, and after are executed successfully. The obtained data for luminosity, temperature, and humidity correspond to the test asserts. We will explore the code in the next video. Thank you for your time.